today we are going to work on simplifying radicals, which is what I talked about in the previous lesson. So just to remind you what I'm talking about, that was when I did this. When I couldn't take the square root of 8, so I broke it down into what perfect square went into it and how many times. That's called simplifying a radical. So that's what we're going to work on in this lesson. So the last lesson, we just had a brief exposure to it, and this lesson, we're going to just work it thoroughly. Okay, so the example in the box shows you the square root of 54, and it shows you that it's broken down into square root of 9 times square root of 6. So make sure when you break down a square root that you put square roots over both of the numbers that multiply to make you that. And then I always suggest putting the perfect square first, because that's the one that can clean up into the pretty number. So the square root of 9 is 3, but then you can't take the square root of 6, so you just recopy it. So then your answer ends up being 3 square root of 6. Okay, so in order to do this lesson, we need to have our perfect squares ready to go. So here we go. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. I'm going to keep going. 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15. I'll stop there. All right, now 1 is a perfect square, but because it goes into everything, I'm going to just ignore him. All right, and then I showed you another example worked out. 50 got broke into as square root of 25 times square root of 2, and then the square root of 25 made a 5, and then you can't take the square root of 2, so you recopy. All right, so let's say you struggle knowing what might go into it. So this is what you do. So I'm going to try to break down this 98. Now this is a hard one for people. So whatever's under the radical, you put that in your calculator, and you start dividing by numbers in the list. Okay, so first I'm going to try 4. If you get a decimal, it doesn't work, so you move on. So then I'm going to try 98 divided by 9. Didn't work. 98 divided by 16. Didn't work. 98 divided by 25. Did not work. 98 divided by 36. Nope. 98 divided by 49. Okay, that works. And if your answer can't be divided by any of these, then you know that that's it. So 49 goes in there twice. Okay, so make sure that you put square roots over both of those. So 49 goes in there twice. And like I said, I always put the perfect square first, because that's the one you can take the square root of. That's the one that cleans up. What is the square root of 49? 7. And if you didn't know, in your calculator, you'd go second x squared 49, and you'd get a 7. So the square root of 49 is 7. And then you can't take the square root of 2 because he's not in the list. So you recopy square root of 2. Now, you may be wondering, the last lesson I had plus minus in front of all my answers, and this does not. So the reason is because this didn't start off an equation with an x in it. So if there had been an equation, an equal sign, and there was an x squared in the problem, then at some point I would have square rooted and I'd slap down a plus minus. But because there's no equal sign and there's no x, then that's why I don't do that. Okay, this next one, 192. Now this is really big, and I gave a big number for a reason. So let's try 192. So I'm going to start dividing by numbers in my list. So I'm going to start with 4. Now 4 works, but here's the deal. If your answer can be divided by any of these numbers in the list, you need to keep searching. And 48 can be divided by 4. It also can be divided by 16. But as long as it can be divided by something in the list, keep going. There's somebody bigger. Okay, let's try 192 divided by 9. No. 192 divided by 16. Okay, that works. Now look at your answer. Can 12 be divided by any of these numbers? Yes, 12 can be divided by 4. Okay, so there's somebody bigger than 16 that can go in. Keep searching. Okay, let's try 25. Nope. Let's try 36. Nope. Let's try 49. Nope. Let's try 64. Okay, now can your answer be divided by any of these numbers? Nope, so that's it. So 64 goes in there 3 times. All right, so 64 goes in there 3 times. Make sure you put square roots over both of your numbers when you break it down. And then clean it up. What is the square root of 64? 8. Because 8 times 8 is 64. And then you can't take the square root of 3, so you recopy it. And that's your answer. Okay, looking at number 4. So looking at the list, do you know who the largest perfect square is that can go into 90? And some of you will be faster at this than others. It's really just your knowledge of your multiplication facts, quite honestly. Well, it's 9. 9 times what makes 90? 10. 9 times 10 makes 90. Okay, and then what's the square root of 9? 3. So your answer is 3 square root of 10. Now, I want to show you something that maybe you've been taught at some point in your life. Sometimes people will work these problems with a little factor tree. So I'm going to show you with the 90, and then I'm going to backtrack and show you with the 192. So with the factor tree, you can use anything you can think of to go into 90. You're not limited by using just perfect squares. So let's say you started with 2 and 45, because 2 times 45 is 90. Then you broke down your 45. 5 times 9 is 45. And then you broke down your 9. 3 times 3 is 9. Well, the way these trees work is whatever you have a pair of, that's what comes out. So since we have a pair of 3s, then 1 3 came out. This 2 didn't have anybody to pair up with, and this 5 didn't have anybody to pair up with, so they're going to be trapped inside, and the things that are trapped inside multiply together, and 2 times 5 is 10. So that's an example of doing this problem with a tree. I want to show you 192. When you have a really big number like this, then it can kind of be a pain. So let's say you have no idea what goes into 192. Well, it's an even number, so 2 goes into every even number there is. So let's just start with 2. So 2 goes into 192 96 times. Let's say you don't know what goes into 96, but you know it's even, so you know that 96 can be divided by 2. Okay, so 2 goes into 48. So then you need to break down your 48. So let's say you don't use a 2 again. Let's say you use 6 times 8. Well, now we need to break down our 6. That's 2 times 3. And let's break down our 8. That's 2 times 4. And let's break down our 4. That's 2 times 2. Okay, let's see what we have pairs of. Here's one pair of 2s, so 1 2 comes out. Here's another pair of 2s, so another 2 comes out. And things that come out will multiply together. I do have another pair of 2s, this one and this one. That makes another pair of 2s. So another 2 is going to come out and multiply. And then this 3 right here didn't have anybody to pair up with, so that 3 is going to be stuck under a radical. And then 2 times 2 is 4. 4 times 2 is 8. And then square root of 3. So this is how you can do this problem with a factor tree, and some of you may have been taught to simplify radicals this way. It's not my favorite because it can be really long and messy, and sometimes people get confused about what they have pairs of, what they don't have pairs of. So I always use this method, what perfect square goes in and how many times. But if you're struggling with that method, you can try to do this if that works for you. As I keep teaching, I'm going to keep teaching this way though. Okay, so 68. I need to find the largest number in this list that can go into 68. And remember, never look bigger than the number itself. So I'm just looking from here to here. So let's just start with 4. 68 divided by 4. And that works. Now look at our answer. Can 17 be divided by any of these? Nope. So that's it. So 4 goes in there 17 times. So square root of 4 times square root of 17. And then what is the square root of 4? 2. And then you can't take the square root of 17, so you just recopy it. And that's your answer. Okay, let's look at example 6. I'm trying to take the square root of 125. Any guesses about which of these perfect squares might go into it? How about 25? And that's it. 5 can't be divided by any of these perfect squares. So that's it. 25 goes in there 5 times. So 25 goes in there 5 times. So square root of 25 times square root of 5. And then what is the square root of 25? 5. And then you can't take the square root of 5, so that recopies. And that's my answer, 5 square root of 5. Okay, now these next ones have letters, and so it may be a little scary, but it's really not that bad. So first, ignore the letters for a minute, and let's just work on the square root of 18. So I want to break it down like I've done the last several problems. Do you know who the largest number is in this list? And don't look bigger than 18. That can go into 18. 9. 9 can go into 18 how many times? Twice. Okay, so what is the square root of 9? 3, and then you can't take the square root of 2, so you recopy. Okay, now let me explain the letters. So a squared means I have 2 a's. B to the 5th means I have 5 b's. Okay, so do you remember when I was doing this little factor tree, I said whatever you have a pair of comes out? Well, that's what we're going to do with our variables. Whatever we have a pair of comes out. You have 1 pair of a's, so 1 a is going to come out. So your 3 is already out, and now an a is going to come out with it. Now, how many pairs of b's do you have? 1, 2. So 2 b's are going to come out, which we write as b squared. But then this b that doesn't have anybody to pair up with is going to be stuck under the radical. So my square root of 2 that I have, I'm going to be sticking a b down there with him because this b didn't have a partner, so he goes under the radical with the 2. And that's our answer. So when you're doing square roots, you're looking for pairs. Okay, number 8. First, I'm going to try to break down the square root of 55. So don't look bigger than the 55. Can any of these numbers divide into 55? Let's say you have no idea. So let's try. 55 divided by 4. Nope. 55 divided by 9. Nope. 55 divided by 16. Nope. 55 divided by 25. Nope. 55 divided by 36. Nope. 55 divided by 49. Nope. The next number is bigger than 55, so no bother trying. So for the first time today, you can't simplify it. So if you can't simplify it, it just stays the square root of whatever it is. Okay, now let's practice the letters. So a cubed means there's 3 a's. B to the 6th means there's 6 b's. And C means there's a C. All right, we're looking for pairs. How many pairs of A's do we have? We have 1 pair of A's, so 1 A gets to come out. This A is going to be going under with the 55. Okay, how many pairs of B's do we have? 1, 2, 3 pairs. So you write that as B cubed. And there's none that don't have pairs, so none get trapped under. And then do you have any pairs of C's? Nope. So this C that doesn't have anybody to pair up with, he's trapped under too. And that's your answer. Are you understanding the letters? Okay, let's skip number 9 and go to number 10. And let's work on breaking down the square root of 175. Okay, so any guesses about what might go into it? Let's try 25. And that's it. 7 can't be divided by any of our perfect squares. So 25 goes in there 7 times. So square root of 25 times square root of 7. Okay, so the square root of 25 is 5. And then you can't take the square root of 7, so you recopy. All right, now let's practice the letters. We have 5 x's, 1, 2, 3, 4, 5. We have 8 y's, 1, 2, 3, 4, 5, 6, 7, 8. And we have 4 z's, 1, 2, 3, 4. Okay, have 5x's. How many pairs is that? 2. So with the 5, 2 x's come out, which you write as x squared. This x that doesn't have a partner goes under with the 7. Okay, we have 8 y's. How many pairs is that? 1, 2, 3, 4 pairs. That's how we write, or that's how we're going to write y to the 4th. Sorry. And then how many pairs of z's do we have if we have 4 of them? 2 pairs. 1, 2, which we write as z squared. And that would be our answer. Kind of a scary looking answer, but that's it. Okay, so that was us working on simplifying radicals. Okay, so now we're going to just practice some simplifying skills that we need to know for when we do like bigger problems. Okay, so we need to know a few rules here. So I'm actually going to start with number 4. So one thing I see from students sometimes is sometimes students think, let me see if I can blow this up a little bit. So sometimes students think that they can cross these 2's off. Well, if you cross the 2's off, then your answer would be 6. But if you did order of operations, 2 plus 6 is 8. Recopy the division bar. Recopy the 2. 8 divided by 2 is 4. Then that's the answer, which is not a 6. So that means that you can't just cancel the 2's out. Okay, so this is the first thing I want to say. When you have a problem that looks like this, you can't just cross off a piece of it if it's attached to a plus or a minus. So if something's attached to a plus or a minus, you can't just cancel one piece. It's either all the pieces do something or none of it does anything. Okay, so one thing I could have done if I wanted to have done it is all 3 of these pieces can divide by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. And 2 divided by 2 is 1. Then I could have worked it. 1 plus 3 is 4. And 4 divided by 1 is 4. So I get the same answer. So what that shows you is you could reduce all 3 pieces, but you can't just reduce one piece. So if something's attached to a plus or a minus, you either do something with reducing all 3 pieces or none of them. Now, example 5 looks different than number 4 because this 2 is not attached to a plus or a minus. So if a number is not attached to a plus or a minus, you can reduce one piece of the problem. So 2 divided by 2 is 1. Shoop, those 2's can cancel, and you can get an answer of 6. So if there's multiplication in the problem, you can reduce one piece of it. But if there's addition or subtraction in the problem, you can't reduce just one piece of it. It's reduce all the pieces or none of it. And there's a reason why I'm telling you all this, and it will come up as we go through the next several lessons. Okay, so backtracking to example 1. Since there are no addition or subtraction signs, I can reduce one piece of it. So one thing you need to know is that if something is under a square root and something is not, those are not allowed to be divided or multiplied. So these I can't reduce, but these I can reduce because neither of those are under square roots. What can you divide 6 and 4 both by? You can divide 6 and 4 both by 2. So what is 6 divided by 2? 3, put your division bar. What's 4 divided by 2? 2. And then that square root of 2 that's there just recopies. So you don't get to do anything with him. So we're just learning some reducing, simplifying rules here. Okay, number 2. Since they're not both under a square root, I'm not allowed to divide or reduce. And they're not both not under a square root. So this is it. That's my answer. Now looking at example 3. Since these are both under square roots, I can actually divide these or reduce them. So this time I can divide both of these by 2, but only because they're both under a square root. Over here, they weren't both under a square root, so that's why I did not divide them both by 2. So square root of 2 divided by 2 is square root of 1, and square root of 6 divided by 2 is square root of 3. And then the square root of 1 is 1, and then you can't take the square root of 3, so we leave it. Now, there is actually more to do with this problem, but I'm not ready to show you yet. So, I'll just put more we can do. But we'll do it later. How about I put theirs? There's more we can do. But for right now, I'm going to stop there. Okay, let's go to the next page. Okay, so now we're going to look at some problems that look a little bit scary. All right, so this takes me back to the rule I was trying to tell you earlier. If something is attached to a plus or a minus, you can't just reduce one piece of the problem. It's either all of it or none of it. Now, since this is under a square root, you can't do anything with just regular numbers, so we're going to ignore him. So look at your 3 front numbers, and what can you divide all of those 3 front numbers by? You can divide them all by 2. So let's do that. So -4 divided by 2 is -2. Put your plus minus. 6 divided by 2 is 3. Put your division bar. 4 divided by 2 is 2. And then that square root of 2 that's in the problem, you recopy it. And that's your answer. Now, don't think you can cross these off or anything. If something's attached to a plus or minus, remember it's all 3 things or nothing. Like this example here, I can't just cross off the 2's because then the answer would have been a 6, but the answer is not a 6. Okay, so this is my answer. Not pretty, but that's him. Okay, number 7, same kind of thing. Since something is attached to a plus or a minus, you can't just reduce one piece of it. It's all of it or none of it. So look at your 3 front numbers, and what can you divide all those by? You can divide them all by 2. So 6 divided by 2 makes 3. Put your plus minus. 8 divided by 2 makes 4. Put your division bar. 4 divided by 2 makes 2. And then your square root of 2 that's in the problem, you just recopy it. And that's your answer. Now, you may be wondering what the plus minus means, so let's talk about it. This means that one answer is 3 plus 4 square root of 2 over 2, and the other answer is 3 minus 4 square root of 2 over 2. So I have 2 answers here. They're just smushed together. Okay, example 8. Look at your 3 front numbers. Can these all 3 be divided by something? No, nothing other than 1. So this is our answer. This time, it couldn't be simplified. Okay, so now, number 9. A big thing I will see from students is they'll automatically try to reduce this to 1/3. But there's a 1 right here that you don't see. And can you divide 2, 1, and 6 all by the same something? Nope. So you're not allowed to do anything with that. Okay, so when we have a problem that looks like this, I didn't talk about it on 6, 7, and 8 because I couldn't break down the square root of 2, and I can't break down the square root of 6, but I can break down the square root of 24. So we're going to break down the square root of 24 like we did on the front page. Who's the largest perfect square that can go into 24? 4, how many times? 6 times. And then what's the square root of 4? 2, and then you can't take the square root of 6, so you recopy it. So I'm going to replace square root of 24 with 2 square root of 6. So I've got 2 plus minus. I'm going to recopy or replace this with 2 square root of 6 and recopy all over 6. Now look at your 3 front numbers. Can you now divide your 3 front numbers by something? Yep, we can divide all 3 front numbers by 2. Okay, so let's do it. What's 2 divided by 2? 1. Put your plus minus. What's 2 divided by 2? 1. Put your division bar. What's 6 divided by 2? 3. And then that square root of 6 that's there, just recopy him. And now it's simplified. So if we can break down the radical, we're going to break it down. And if all 3 numbers can be reduced, we'll do it. And if not all 3 can be reduced, then we don't. Now, example 10. I cannot just reduce the 2 and 4 because there's a 1 in front here that you do not see. And you can't reduce 2, 1, and 4 all by something. Okay, so then I look at my square root, and I can actually do something with that. And this is a perfect square, so it's going to be pretty. What is the square root of 36? It's a 6. So I'm going to rewrite this as 2 plus minus. This is just a 6 all over 4. Now, I can reduce this if I want, but I'm not going to reduce it. I'm actually going to work it out. If there's no square roots, then I can work it out first using the plus sign and then using the minus sign. So if I use the plus sign, that means I have 2 plus 6 over 4. And if I use the minus sign, that means I have 2 minus 6 over 4. So I'm going to work these two separate problems. So what do you get if you take 2 plus 6? 8. And what's 8 over 4? 2. So one answer is a 2. Now let's do this one. What's 2 minus 6? Negative 4. And negative 4 divided by 4 makes negative 1. So this time we end up with two pretty answers. Oh, sorry, you couldn't see that there for a second. So this time we end up with two pretty answers because we didn't have any square roots, because that ended up being a perfect square. Okay, got one more thing to this little lesson here. This is called rationalizing a denominator. I don't like to call it that, though. I like to call it FFOO, which stands for fancy form of 1. Now, that's going to be a little confusing, so I'm going to have to talk about it for a little while. Okay, so first things first. Before I do these problems, I need to talk about a few things. Let's see if we can see a pattern here with something. All right, the square root of 2 times the square root of 2. Now, you may not realize this, but the square root of 2 times the square root of 2 is the square root of 4. Since they're both under the radical, I can actually multiply them together. But then, what's the square root of 4? Just a 2. Okay, let's try square root of 5 times square root of 5. Well, since they're both under a radical, I can multiply them and get square root of 25. But what's the square root of 25? Just a 5. Okay, let's try square root of 8 times square root of 8. Well, that makes square root of 64. But what's the square root of 64? Just an 8. Now let's try one that's really large. Square root of 212 times square root of 212. In a second, can you give me the answer? 212. So if you didn't notice the pattern, whenever you take a square root times itself, shoop, out it comes. A square root times itself, shoop, out it comes. A square root times itself, shoop, out it comes. A square root times itself, shoop, out it comes. Okay, we need to know that so we don't have to work so hard on these problems down here. Okay, next thing you need to know. When you work with radicals, you cannot have a radical in the denominator. So to get rid of whatever radical is in the denominator, you multiply by whatever is in the denominator over itself. This is my fancy form of 1. So you know how anything divided by itself is 1? Let me show you. 2 divided by 2, 1. 8 divided by 8, 1. 200 divided by 200, 1. 150 divided by 150, 1. Anything divided by itself is 1. Well, let me try this guy. Square root of 5 divided by square root of 5. Square root of 5 divided by square root of 5. 1. But it's a weird way of writing a 1, so that's why I call it my fancy form of 1. Foo-foo! Okay, so once you figure it out, we multiply straight across, straight across. So when I multiply my numerators, I can't actually multiply them together because one is under a radical and one's not. So you basically just recopy it. 2 times square root of 5 is 2 square root of 5. Now let's put our division bar. Now let's multiply the denominators. Now, remember the shortcut? When you take a square root times itself, that number gets to shoop, slip out of the radical. So the step I'm skipping is square root of 5 times square root of 5 is square root of 25? Because I know the square root of 25 is just a 5. So I would like you to know that when you take a square root times itself, that number slips out of the radical. Now, reducing. I'm not allowed to reduce these two because that's under a radical and that is not. So I can't do anything with those. So the only thing I could possibly reduce is the 2 and 5. But 2 over 5, that doesn't reduce. So that's my answer. 2 square root of 5 over 5. And see, I no longer have a radical in the denominator, which is what I'm trying to avoid, because you can't have radicals in the denominator. Okay, example 2. Once again, I'm presented with a radical in the denominator, and I can't have that. So I need my FFU, my fancy form of 1. Remember, it's going to be whatever is in the denominator over itself. And then you multiply straight across, straight across. Okay, so when I multiply 3 times square root of 3, I can't actually multiply them because they're not both under a radical, so I basically just recopy. So 3 times square root of 3 is just 3 square root of 3. Now we get to do our shortcut with the denominator. When you take a square root times itself, that number gets to slip out of the radical. So you get just a 3. Now this time, this one can reduce. I can reduce these because neither of those are under a radical. So 3 divided by 3 is 1. So you have 1 square root of 3 or just square root of 3. Okay, example 3. I can't have a square root in the denominator. So do you know who my fancy form of 1 is based off of the last 2 problems? Square root of 2 over square root of 2. It's whatever is in the denominator over itself. This is our FFU, our fancy form of 1. Now let's multiply straight across, straight across. What do you think 3 times square root of 2 is? 3 square root of 2. You can't actually multiply them because they're not both under a radical. Now the denominator I can shortcut because I'm taking a square root times itself. And when you take a square root times itself, that number gets to slip out of the radical. Now, these guys I'm not allowed to reduce because he's under a radical and he's not. These two I'm allowed to reduce, but they don't. 3 over 2 does not reduce. So that's the answer. 3 square root of 2 over 2. Okay, one more. So, since these are both under square roots, if I could actually divide these numbers, I would divide them. Or if I could reduce them, I would reduce them, but they don't divide or reduce. Okay, so can't have a square root in the denominator, so it's fancy form of 1 time. FFU! Who do you think our FFU is? Square root of 10 over square root of 10. Then I'm going to multiply straight across, straight across. Now this one's different than the last 3 because this time in the numerator, both of these numbers are under a square root. So this time I can multiply them. So square root of 7 times square root of 10 is square root of 70. So if they're not both under a radical, like the one before, these weren't both under a radical, so it just stayed 3 square root of 2. But if they're both under a radical, you can actually multiply them, and square root of 7 times square root of 10 makes square root of 70. And then the denominator, because I'm taking a square root times itself, I get to do the shortcut. And when you take a square root times itself, that number gets to slip right on out. And then these, you're not allowed to divide or reduce because he's under a radical and he's not. So that's my answer. And that's all for this lesson. Smiley face.